Hello friends, myself Chandra Kumar. I am taking lecture machines for the mechanical engineering students. In continuation of the previous lecture, we have just continued about the starting of induction motors, which we already covered in the previous lecture. With the help of the direct online starting, we can start the induction motor. We can use the auto transformer just to give the start of a three-phase induction motor. Now, in continuation of this, we can just looking over another method which we are offering for starting of a three-phase induction motor. That's called the start at the starting method. The connection diagram will be shown over there, and with the help of this one, you can find out that whenever this will be the supply, there is a TPDT three pole double throw switch is there that will be connected over this side. So there is a again one more switch are there which will indicate whether TPDD is there, and one side it will be short circuited, another side will be connected in the just in the opposite or the in a reversible direction connection between the A, B and C. So you can find out over this side that there is a C and B, but over here it will be a B, C, A. So it will be just making a delta kind of connection whenever we have to just give the motor. So on the left hand side we are finding that it will form a star type connection, or whenever we are just transform it from the left hand side towards the right hand side, then it will form a run operation and it will converted the connection into a delta. So it will this type of connection which will indicate that it will be a star to delta conversion type starting method of a three-phase induction motor. This method is used for the motors designed to operate in delta connected winding. The terminals are marked for the phases of the stator. Now let us see this method works. The stator phases are first connected to the star by the help of the triple pole double throw switch, which is indicated as a TPDT switch. In the diagram, the position is marked as 1. Then after this, when the steady state speed is reached, the switch is thrown to position 2 as shown. Now let's analyze the working of the above circuit. In the first position, the terminals of the motor are short circuited, and in the second position from the diagram, the terminals A, B, C are respectively connected to BCA. Now let us derive the expression for starting torque in terms of full load torque for the start delta starting method. We have various quantities that involved in the expression for the starting torque are written as all TF as the full load torque, TS stands for the starting torque, IF as the per phase rotor current at full load, IS as per phase rotor current at the time of starting, SF as the full load slip, SF as the starting slip, R2 as the rotor resistance, WS as the synchronous speed of the motor. Now we can directly write the expression for the torque of the induction motor as best known, because this expression we already discussed in the previous lecture. On the help of the above expression, we can write out that TS equal to TS upon TS equal to IS upon IF whole square times SF. Here we have assumed that the rotor resistance is constant and does not vary with the frequency of the rotor current. Let us assume the line voltage to be V1, then the per phase starting current when connected in star position, it will be ISS, which is given by VSS, VISS equal to VI upon 1.3 times Z. When stator is in delta connected position, VS starting current becomes ISG equal to VI upon Z, where ISG is root 3 times of ISS, or IFD equal to ISS. From the above expression, we can find out that the TS upon TF equal to 3 times of ISG upon IFD square into SF. This shows that the reduced voltage method has an advantage of reducing the starting current, but the disadvantage is that all these methods of reduced voltage causes the objectionable reduction in the starting torque too. Starting methods of wound rotor motors, we can employ all the methods that we have discussed for the starting of the square induction motor in order to start the wound rotors motor. We will discuss the cheapest method of starting the wound rotors motor here. Additional of external resistance in rotor circuit. This will decrease the starting current, increases the starting torque, and improves the power factor. The circuit diagram is shown. In the circuit diagram, the three slip rings shown are connected to the rotor terminals of the wound rotor motor. At the time of starting of the motor, the entire external resistance is added in the rotor circuit. Then the external rotor resistance is decreased in steps as the rotor speeds up. However, the motor torque remains maximum during the acceleration period of the motor. Under normal conditions, when the motor develops low torque, the external resistance is removed. After completing this article, we are able to compare induction motor with synchronous motor. Point-wise comparison between the induction motor and the synchronous motor can be analyzed over here. Induction motor always operates at lagging power factor, while the synchronous motor can operate at both lagging and leading or unity power factor. And an induction motor, the value of maximum torque is directly proportional to the square of the supply voltage, while in case of synchronous machine, the maximum torque is directly proportional to the supply voltage. In an induction motor, we can easily control speed, while with the synchronous motor, in normal condition, we cannot control speed of the motor. The induction motor has inherent self-starting torque, while the synchronous motor has no inherent self-starting torque. We cannot use induction motor to improve the power factor of the supply system, while with the help of use of synchronous motor, we can improve the power factor of the supply system too. It is a simply excited machine, means there is no requirement of DC excitation, while the synchronous motor is doubly excited motor, means there is requirement of separate DC excitation. In case of induction motor, on increasing the load, the speed of the motor decreases. Why? With the speed of synchronous motor remains constant. So these are the basic differences between the synchronous machine and the induction machine in the operational and the advantages and the disadvantages basis too. So we will discuss the synchronous machine in future lectures. So we will discuss we will